Hey everyone, in this tutorial we're going to take a look at how to use Blender to create our own unique CC Smart Hair along with its dedicated textures. Smart Hair elements consist of everything from complete hairstyles to partial hair section replacements. This allows you to combine unique Smart Hair elements to generate dozens of different hairstyles. The digital human hair shader provides additional texture maps which allow you to create more realistic hair via the ability to control the flow of highlights as well as the color of roots and tips independently. Smart Hair also conforms perfectly to any morph changes on your character's head and body as well. Okay, let's get started creating our first texture here in Blender. We'll use a 4096 by 4096 resolution for our render and switch to render mode. Then add a light so we can see everything better. I'll then select and reposition the plane to use as our particle hair emitter. Once we add that in, we can adjust the density and length, and use clump to simulate natural hair clustering, and braid to control the twisting effects. You can also enter particle edit mode and use the brushes to refine the hairstyle. In addition to dense hair strands, we also need to create some that are more sparse. Using the same process, we can use another plane to emit our hair strands, resize it, and decrease the density. Once we've got something satisfactory like this, we need to convert the particle hair to mesh in order to prevent the emitter plane from being rendered. We can do this from the modifiers panel. Once we do this, we can hide or delete the original plane. At this point, the hair strands are all just single-sided curves. To give them volume, we can merge all of the strands and apply the screw modifier to add some body, and then a solidify modifier to better control the thickness. In order to prevent the tips from being too thick, we can also use a vertex group and utilize the solidify effect. First, create a vertex group, then enter into edit mode and select only the hair roots to be affected. We can also add a subdivision modifier in order to give the hair a smoother overall result. Okay, next let's look at how we can use our shader node to create the various textures needed to create our completed CC Smart Hair. Let's tackle the opacity map first. For this, we only need a monochromatic texture map, so we can use the most basic default material. For the ambient occlusion map, we can add a color ramp node which will let us adjust the contrast, as well as an emission shader so we can visualize it in the render window. Next, let's create a Z-depth map by adding the camera data to output the Z-depth information. We can then add a map range to adjust the intensity, being careful not to make the values too extreme, which might end up affecting the hair color itself. Next up is a flow map, which we can start by adding a geometry node in order to capture the world normal information. Here we'll want to use a separate XYZ node to separate the info to those respective axes. The flow map only requires horizontal x-axis and vertical y-axis information. We can add and mix this data, then pass it through a combine RGB node in order to convert them into color. Let's now create our ID map by using the random island in the geometry node to assign different color information to the objects. After that, we can adjust the color distribution for each hair strand by using a color ramp and map range. Lastly, we need to create our root map. I'll press Ctrl T on the node to bring up the object's coordinate information and mapping, which allows us to control rotation and translation. From here, I'll add yet another color ramp to adjust the shadow contrast, and modify the mapping direction so that the gradient goes from the root to the tip of the hair. Finally, we need to output all of the material information. We can use an AOV output to add render passes and quickly generate multiple textures at once. We need to add one to each material section and connect the color information to our AOV output node. In this case, Emission is only used to make the color info visible in the render window, so it won't utilize an AOV output node. Be sure to name each one accordingly. Once it's all connected, go to Render Layers and input all of the AOV channels into the shader AOV. This will ensure that during the cycles render, all of the passes will be output together. Once it's set up, go ahead and proceed with the rendering. Here you can see the final versions of all of our individual texture maps. Once the rendering is complete, we need to create padding for the texture. Since the hair itself is high resolution, MIP mapping can cause noise or blurring at the edge of the hair. Padding allows us to extend the edges of your texture to avoid this issue, and also helps prevent artifacts, ensuring that the texture remains clean and sharp once the MIP maps are applied. I'm going to use the free X-Normal plugin with Photoshop to create our padding. From the filter menu, we can select dilation, then set an appropriate expansion range. This process helps to extend the edges of our texture, helping to reduce noise and blurring once the MIP maps are used. Our opacity map doesn't need padding since we only need the shape of the hair strands in this case, so we just need to add in a black background. When exporting your texture, you can use JPEG format in order to avoid large texture sizes that may affect performance in CC. Okay, so that's the basic process for creating the necessary textures for CC Smart Hair. There are various other ways to connect texture nodes in Blender, so feel free to experiment with whatever workflow works best for your scenario. In the next video, we'll talk about how to create the hair mesh in Blender and import it to CC, finally combining with our texture maps to complete our CC Smart Hair. I'll see you there.